Alright, let's take a look at some other redox reactions that don't fit into any other category. So you're going to start recognizing oxidation states because you assign the same ones over and over and over again. Oxygen tends to be -2, hydrogen +1, chromium is 6 or 3. And you recognize those because those are the most common oxidation states for those elements. So sometimes an element might be in an extreme oxidation state, so one that it doesn't like to be in, and so it'll undergo a redox reaction to get to a more suitable oxidation state. So for our example, we'll take a look at hot iron oxide, which is a solid, so that would be Fe2O3. And that's going to react to form carbon dioxide and regular iron. So what's happening here is if we just plug the oxidation states in real quick, this iron is at +3, this carbon is at +2. And so you're probably going to recognize that carbon usually isn't +2, tends to be +4. And so once we know that carbon wants to be +4, we can then assume that in this reaction carbon is going to try and gain that oxidation state that it likes. So when it forms carbon dioxide, now it is at +4, where it wants to be, and iron is now at 0. So acids are used a lot in redox reactions. They help drive it because they produce ions in the solution that can help transfer those electrons from one substance to the next. Now we're going to talk more in depth about acids later on, but just for now what you guys need to know is that acids, strong acids, generate high amounts of H+ inside of a solution. So they break apart to make H+. Bases, on the other hand, break apart to generate hydroxides or OH-. Alright, so here's our first acid redox reaction. So all strong acids, and we'll talk about what strong acids are later, except nitric acid, can oxidize metals very easily. And so what happens then is we just throw X here, so that's any metal. Now the hydrogen is actually a strong enough oxidizer that it can rip electrons away from the metal and convert it into a cation, thus generating hydrogen gas, because the hydrogen is going to go from an oxidation state of +1 to 0, and a metal cation, because it goes from 0 to plus whatever its charge is. Now in order to figure out these kind of reactions, you have to know the oxidation states of metals. And so, like iron, it's going to have multiple oxidation states, and you know what those multiple oxidation states are. Other metals, like the alkali metals or alkaline earth metals, you should know those as +1 and +2 respectively. So here's an example. This one has us reacting magnesium with hydrochloric acid, which is a strong acid. And so we write just the net ionic equation. That's going to involve magnesium, which is a solid, reacting with H+. And what's going to happen is that hydrogen is going to rip the electrons away from the magnesium, thus generating hydrogen gas. So what is the typical oxidation state of magnesium? Well, it's going to be +2, so it's not going to generate magnesium plus, it's going to be 2+, which means we now need to balance this reaction. So if one hydrogen is going to steal one electron, then in order to balance this we're going to need 2 hydrogens, since magnesium has 2 electrons to give away. And so what that means is we would have 2H+ generating magnesium and H2. And so that balances the reaction. It also balances the charges.